Hello everyone. Today I will show the main difference between manual and automatic balancing, and main difference between static system and dynamic system. In this short video you will understand how the manual balancing valves work and how the automatic balancing valves work. Here we have demo panel, which might look complicated, but it is really simple one. It consists of 3 risers. So here is riser number 1. Imagine there are more radiators upstairs. So first riser, second riser, here is supply line, here is return line, this one is closed. Here we have 3 types of balancing valves. These 2 are closed and this one is open. Third riser, the last one, is here, return comes here, filter, and it returns to substation. We have 2 pumps, one is free speed pump, green one is automatic with frequency converter. And here is supply pipe, goes to first riser. So all automatic balancing valves now are closed, manual one is fully open, closed, closed, fully open, closed, closed, and this one is fully open. As you might predict, first riser gets maximum flow, and here we have flow meter and can check flow at the first riser. So first riser we have 300 liters. Second riser is here, we have 220 liters. And third, the last riser, we have 180 liters. Okay? So there is a problem in the house that last riser is not heating enough and the first riser is heating too much. So there might be idea to balance the system, and somebody would advise to put manual balancing valves on each riser. Let's try to put manual balancing valves here and to balance system with manual balancing valves. Let's say we need 200 liters for each riser, first, second and third. So now I simply regulate manual balancing valve and I'm trying to achieve 200 liters. Okay, I want to balance it at 200 liters. Okay, first riser is balanced. Now I balance second one. I squeeze balancing valve and set 200 liters. Okay. The last one was 180 liters. Squeeze maybe a little bit just to have precisely 200 liters. Let's check first riser. Does it change? Oh, it changed maybe a little bit, so I adjust a little bit, second one a little bit. Okay, so we have now 200 liters at each riser. System is balanced, and now each riser gets the needed heating capacity. People are happy. Of course, tenants in the first riser might be not so happy because they have less flow than they had, and now they need to shut down their windows. Riser in the middle might not feel big difference before and after balancing, and tenants living in a last riser, they are very happy because they have designed flow and they have enough of heating. So now all 3 risers are heating equally, and we have constant flow static system. There is no regulation, only manual balancing valves installed. After heating season, tenants get an idea that maybe they would like to regulate radiators. Maybe they would like to put something on radiator and to have possibility for regulation of flat temperature, of each room temperature. So they collect money, here comes installation company, and they put thermostats here on radiators. Here already we have put remote regulation. Here is impulse tube, and thermostat is right here. So I regulate here, and thermostat closes valve using this impulse tube. So, for example, if I close, you can see flow is shutting off. If I open, it opens again. So imagine situation where half of the building is directed to south and another half is directed to north. So probably on springtime, south side would close automatically because thermostats are automatic. If we set it at 20 degrees, if it reaches 20 degrees, it simply closes the flow. So 30% of system close flow, another 30% close of the flow, and take a look what we have. We had 200 liters at the last riser, and now we have 350 liters at last riser. So if we close two risers, the one that was, we say, balanced, it was limited to 200 liters, now is overheating, and now we are getting noise through radiator, and tenants are not happy. So they are calling to maintenance company to see what is happening. Okay, maintenance company comes, they see the balancing valve, they see that there is too much flow, and they simply squeeze the balancing valve. The idea is maybe somebody disbalanced system, or maybe somebody did something and they squeeze this riser to 200 liters as it was before. Okay, night time comes, and this 60% of system opens. Okay, so it opens, it needs heating, and let's take a look what flow we have on risers. So on first riser we have a little more than 200 liters, which is okay. Riser number 2, we have 230, 240 liters, also it is okay. And riser, the last one, which we squeezed, or which we just limited to 200 liters, now is getting 120 liters. People again are not happy. They call the maintenance company and they say top of the radiator is hot and the whole radiator is cold. Maintenance company comes, they connect to manual balancing valve, they see there is really not enough flow. What to do? We need to open up the balancing valve. And now they open balancing valve and set 200 liters. Okay, they set 200 liters. Now everything is open and everywhere we have 200 liters. So at full load, then everyone is open, we have our design flow 200 liters for each riser. But unfortunately, sun comes again on a springtime and again heats half of the building, and half of the building doesn't need heating. And again, we have overflow on the rises who are on the north side and still need heating. And again, they have noise, and again, they call to maintenance company. Maintenance company comes, and they see that, oh my God, we already came here 2 times. Once it was too much, then it was too low flow. Now again, we have too much flow. They know that if we regulate this manual balancing valve, they will need to come again next day or after 2 days. Then sun goes out and clouds comes. What they do adjustment of pump. Okay, so here I cannot regulate a lot because it already runs on a first gear or first speed. So I just squeeze this manual balancing valve next to pump, looking at this flow. So I need to set here 200 liters. Okay, I set here 200 liters, my design flow. Let's check all other rises. So here we have 0. Okay, here we have 0. Second heat 0. First one is also 0. During night time, we have colder weather outside, so all house thermostats are opening. So again, we need full capacity of our heating system. And now take a look what we have in our system. First rise it was 200 liters. Now we have something like 70 liters. Here we have 200. We had 200. Now we have 70 liters. And the last one also 70 liters. So now every tenant is calling to maintenance system and asking questions. Why our radiators are cold? And what are you doing with our system? It is or heating too much or heating too less. And there is nothing much to do than to come again for maintenance company and to increase pump head to fulfill needed requirement. So I just open this manual balancing valve and I set the same flow as it was, 200 liters for each rise. Okay, what to do? Somebody would advise that this 3-speed circulation pump is too old and doesn't work. And you would need to throw it away and put a new one modern circulation pump with frequency converter. So I will do this in a few seconds. I simply close this 3-speed pump and open up a electronic one. Now we just need to set it on the right speed to have the same flow. So I make a little adjustment to have the same flows. Okay, let's check with camera. Do we have the same flows? 200 liters, 200 liters second one, and the third one is also 200 liters. Let's check of setting of circulation pump. What does it show in its window, in its screen? Okay, it shows something like a 5.1 meter of water. It is 51 kilopascal. Okay, time to try to close something. Here comes sun comes again, and thermostat closes 30%, 60%, 50%. Let's take a look at the last riser. Oh my God, what we have? We have again overflow. Maybe not so big, almost the same actually, but a little bit less. With 3-speed pump it was 350 liters, with automatic pump it is 320 liters. Riser number 2 is closed, riser number 1 is also closed. What to do? It looks like we did what somebody advised. We put electronic pump which should work and should react on our thermostats and should reduce speed of motor and should deliver less flow, but seems it doesn't work. And in reality it doesn't work in systems where we have long pipes, where we have big resistance in pipes. In this case, this demo panel might look like a very small one, but we have between risers here, we have manual balancing valves, which in reality are not used. So here we have manual balancing valve, and here between risers we have manual balancing valves, which are a little bit squeezed, and we have resistance on pipes, and that's why pump cannot understand. In reality it would be long piping, like a maybe not high house, but very long one, or a house with floor heating where we have a lot of piping in concrete. So in this kind of systems, automatic pump does not work. Somebody might advise to change setting of pump, because now it works on delta PC, constant pressure. It is set to constant pressure. We can change our curve of pump and make it work to variable curve. So let's take camera closer, and I will show now how we adjust. Okay, so I just hold the button and just simply change, it was here, the curve to variable one. Okay, pump head is the same, 5.1 meter. Now take a look what happened to our flows. I just open all risers. Okay, everything is open. I did not balance anything. I just set pump head from constant to variable. And now I have shortage of flows in each riser. So to make experiment fair, I need to increase pump head with different setting to have the same flows in each risers, 200 liters. So I will now increase pump head, just like this, looking at risers to have same 200 liters for each riser. Okay, 200 liters for each riser. Let's check a setting of pump. How much we have now? it is okay, it is 10 meters. It was 5.1 at constant curve, and at variable curve we have 10 meters. But we reaching our 200 liters for each riser. So sun comes again and closes 30% of the system, and again 60% of the system. What we have for the last riser? For last riser we have 310 at constant pressure. It was 300 and something like a 30. And variable we have a little bit less, but still it is 210, so it is 50% more comparing to our needed 200 liters. So again, the same problems with circulation, the same problems with automatic pump as with three-speed pump. And that's why manual balancing valves cannot work with automatic pumps or electronic pumps with frequency converters. So if you have variable system, variable means you have thermostat or thermostatic heads on radiators here. If you have thermostatic heads on radiators, you cannot use manual balancing valves. So only one good solution is to use, of course, automatic pump, because it is double efficient, talking about electricity, comparing to old-fashioned three-speed pump. But balancing valves needs to be automatic. And now we will see how it works with two types of automatic valves. First one will be done for ASV-PV, delta P controller. We have here balancing valve, which is more or less used for connection, to have possibility for connection for impulse tube, and here goes impulse tube, and membrane maintains needed pressure on our riser. So I close these manual balancing valves, close them all. I open up everything in the system. I open up pressure controllers, delta P controllers. Okay. While commissioning automatic balancing valves, we always advise to set pump head at maximum speed and to set it at constant pressure. So I don't want circulation pump to play with flow than I do commissioning with manual balancing valves. After we did commissioning, we always need to make pump optimization, and I will show how to do it. Okay, so maximum speed, delta PC, constant pressure. We have some kind of different flows. It is not balanced, so I need to balance right now. I can balance with pressure controller. So I have possibility to regulate flow with pressure controller. So if I open up, flow decreases. So it works in opposite way. If I close, like a clockwise, if I close clockwise, it increases flow. So let's set, for example, 100 liters. Also, I can regulate here with manual balancing valve, but better is not to squeeze this balancing valve too much, because it takes authority on itself, and then we lose authority for thermostatic radiator valve, which in simple way means we lose accuracy of regulation of temperature for radiator thermostat. So I set 100 liter here. I set 100 liters here. Okay, and let's set 100 liters here. Okay, so we have everywhere 100 liters, 100, 100, 100. And sun comes on our horizon, heats up multifamily house. What we have the same 100 liters. Doesn't matter how many neighbor rises we have, just closed. So second one is closed, first one is closed, and the last one is keeping 100 liters as we balance. So it has no influence and it has no difference how many risers are really open. Okay, so pump now is working on maximum speed. I can play a little bit actually. For example, let's predict our circulation pump just broke up. This new one, brand new pump just broke up, and we still have in our we still have our old pump. So I just put an old pump, open up the balancing valve, I switch on the maximum third gear, third speed, and let's check how many flow I have. First one is still closed, second one is still closed, and the last one remains the same 100 liters. So it doesn't matter if somebody plays in a substation with circulation pump, you will never have too much of flow on your riser, or doesn't matter if you have automatic balancing valve on your apartment. If it is manifold system, it might be that you have pressure controller on your apartment, so you are fully independent of all your neighbors and fully independent from your substation circulation pump. Okay, let's switch again automatic pump. I close this 3-speed pump, open automatic one, and open everything in a system to have full to have flow everywhere. So I have 100, 100, and 100 liters everywhere, and now I need to make pump optimization. Okay, so we need actually two guys. One guy is checking how much liters we have at the last riser, and another guy goes to substation and simply regulates the circulation pump. Okay, so first what we do, we change setting from constant to variable. We immediately hear that pump noise is reduced now, and it works now more quiet. We still have 100 in each riser, so I can go down with pump. Maybe you can show why I just go down with I go down with speed of circulation pump. Okay. Or maybe too much. Maybe too much. Okay, 100 liters. But not everywhere. 100. I go back to the last riser. Okay. And setting of pump. Okay, setting of pump is 5.7 meters. So now pump head is optimized, and our system is balanced at full load, and also at partial load. Okay, the last automatic balancing valve is ABQM pressure independent balancing and control valve. So I closed pressure controllers, ASV-PVs, and I just leave. Okay, just open this one, this one's, everyone is open. Okay, I can now switch off circulation pump, because for commissioning system with ABQMs or pressure independent balancing control valves, we don't need to see flow. We can set flow without flow. And let's come camera closer. Here I will show what we have here. 200 liters we have maximum. So this is maximum flow. What this kind of valve can maintain? So at setting 0, it is of course closed, but at setting 10 it would have 200 liters, and at setting 5 it would have 100 liters. So I set setting 5, I don't know, is it visible here? Probably it is visible. Yeah, setting 5. So I do the same for all risers. Flow is not running because pumps are now closed. So I set 5 everywhere, and we will see what is happening. Okay, so I already made settings. I switch on pump, and I immediately go to pump setting, and I increase maximum pump head to have right flow everywhere. And let's check now how much flow we have in each riser. 100 liters, almost 100 liters, and here almost 100 liters. Maybe need just some adjustment, readjustment, but more or less accuracy is quite good, plus minus 10% is normal. And without measuring tools, we already commissioned the system without water. And now let's check what happens. Then sun comes again. I close one riser, close another riser, 60% of our system, and we have last riser, the same 100 liters. So it is keeping what we have set. So for dynamic systems, for variable speed in a system, variable circulation, we have two types of balancing valves. Pressure controllers, they consist of two, balancing valve and pressure controller. They cannot work separately. They work always on pairs. Second one is everything inside, in the pressure independent balancing and control valve. So in some applications we use pressure controllers. In other applications we use pressure independent valves. In radiator systems, pressure independent valve to use for risers is not okay. It is better to use pressure controller. There is a book, or there is a manual about many different systems, and there you can check which valve is better for which application. So these ones are mainly used for radiators and for floor heating systems. Pressure independent ABQM is mostly used with fan coils, chilled beams, air handling units, air curtains, one pipe heating system renovation. Okay, so more or less, I hope it was useful. Now you understand main difference between manual balancing and automatic balancing, and what 3-speed pump is and what automatic pump is, and how systems work in different conditions. So thank you. Goodbye.